In R2, let's take a look at the picture. If I have this vector right here, which let's say it's a vector of length 1, and I look at the angle. Well, if it's a vector of length 1 with this angle here, its x-coordinate is cosine of theta, and its y-coordinate is sine of theta. So, can we turn this into a statement about vectors? Notice that u dotted with the first standard unit vector e1, remember that's 1, 0, that this guy is equal to the cosine of theta, comma, sine of theta, dotted with 1, 0, which is the cosine of theta. More generally, if we're given two vectors, u and v in R2, so we can use the law of cosines to compute u dotted with v is equal to the length of u times the length of v times the cosine of theta. I encourage you to go and actually check this with some examples. So here, what is theta? Theta is the smaller angle between these two vectors. So it's the smaller, so here's u and here's v, smaller angle. So let u and v be in Rn. Then we define the cosine of theta to be u dotted with v over the length of u times the length of v. Here we want to use the smaller angle, so in other words, theta is less than or equal to 180 degrees and greater than or equal to 0. In other words, theta is the inverse cosine of u dot v over the length of u times the length of v. So a couple of caveats. Neither u nor v can be 0. So these guys can't be 0. And that makes sense because, I don't know about you, I don't really know how to define the angle between something and the 0 vector. It doesn't make sense. It doesn't even make sense in R2. So the next thing we can ask, is this well defined? Well, we know that the cosine of any real number is always between -1 and 1 inclusive. So we need the same thing to be true of this guy here. How do we know it's true? Well, it follows from a theorem. This theorem is called the Cauchy-Schwarz inequality. In R2, it follows from the law of cosines, and I encourage you to check that. In general, I'm not going to prove this, and I can't remember off the top of my head if the book proves it or not. However, it is a very important theorem. All right, that's it.